I will share my screen then. Yeah, okay. So, okay. Do you see? Yeah, okay, cool. Yeah, so as Adam said, I'm gonna talk to you about the Neptune database today. So for those of you who do not know the database, it's a database primarily of microfossil occurrences in deep sea sediment. So of course, I'm gonna first explain what are microfossils and deep sea sediments, just to be sure that we're on the same page. So this is the 4 main groups of microfossils we have in the database. Radiolarian, diatom, planktonic foram, and calcareous nanofossils. The first 2 made shale in silica, the 2 others make shale primarily in calcite. Radiolarians and planktonic foraminifera are heterotroph, diatom and calcareous nanofossils are autoautotroph. So what's remarkable about the fossil record is that basically deep sea sediment are mostly composed of them. It's an incredibly dense fossil record. In a single gram of sediment, you can find from 1,000 to millions of specimens, particularly for calcareous nanofossil and diatom, who are very small. Not only that, but we have a remarkable amount of sample available, thanks to an international collaboration that's been going on since the 60s, called first the Deep Sea Drilling Project and the Ocean Drilling Program, and then the Integrated Ocean Drilling Program, and I think now it's called the International Ocean Discovery Program. It's planned to end next year, but maybe there's going to be a successor. There's been more than 1,500 sites drilled in the world ocean for scientific purposes. You can see the map of, it's not even complete yet, but you can see the magnitude of the geographic spread of the data. And it's mostly in situ, undisturbed marine sediments from the late Jurassic to the present. I think there's a few sites that have a bit older sediments, but not much. And most of them are really primarily composed of microfossil, in particular if you're really offshore in the deep sea, in a context of a continuous sedimentation plus or minus hiatus. So it's an absolutely remarkable fossil record. And because of this, in the early 90s, late 80s, early 90s, began germinate the idea of actually making a database out of that so that we can use it to actually test hypotheses on microevolution, which is something that has been sparked by the work of Sepkowski, obviously. So it started in 89, as far as I know, but I was 6, so I wasn't there to know that. At the ETH in Zurich, in the lab of Tiernstein, with Cynthia Servato and David Lazarus in particular working on it, but I'm sure there was a lot of other people. As I said, I was just an infant at the time, so I do not know exactly who was in the working group. But yeah, so they started making this database in a language that don't exist really anymore, called Fourth Dimension. It was not available online, obviously, because there was no such a thing as online. And the database design was really driven by the technical limitation of the time. And you have to remember that at the time, an hard drive, well into the 90s, actually, an hard drive was less than 100 megabytes. So there was really no place for additional data, in particular, no place for metadata. So the database was really at its simplest form. You can see that they did publish a few publications at the time, but really just about the structure of the database and the basic content. And it lasted until 95. Later on in 2001, when Cynthia Servato arrived in the moved to the US, she restarted Neptune in the context of a grant from the NSF of the project Kronos was called. So there was a lot of people involved with that project. They moved to a more modern setup with PostgreSQL. They made a first website, which is why you can see that the number of publications using Neptune actually started skyrocketing because it was really available to the international community. So they put in a lot of data in and unfortunately in 2008 funding stopped, and as it was one of the lesser priority from the Kronos, it was more or less abandoned actually. And a few years later, we even have some users who started reporting so that the data was corrupted because they had a problem with their server. So in 2011, I think, yes, we got a small funding from thanks to Oslo, our colleagues in Oslo, with which we moved Neptune in Berlin based on a backup from the Kronos version of Neptune. That's from that point on, we started calling it Neptune Sandbox Berlin, because at the time we started trying a lot of new stuff in it, and sandbox aspect. In 2013, I was hired to make a website for a couple of months for the database. So that's when I joined the development team. And in 2014 and 15, thanks to ICO Particle, we had some leftover funds in a European Science Foundation project. We were able to actually, they were able to hire me to actually expand significantly the database, both in terms of content, but also in terms of structure. We modified it significantly to put back all the metadata basically into the database. Just to give an idea, this is what the database used to look like, the structure of the database. And this is what it looks like after these 2 years of expansion. So I'm going to show a more palatable version of this table. So basically, what we had was originally what we call a taxonomical backbone, where all the taxa are defined. Then a bunch of metadata on the samples, like where it come from, what age it is, what depth it is, etc. Which now we actually added a bunch of other data on the paleo coordinates, etc. And then the convergence of those two sides of the database is like the meat really of the database, which is this table that contain all the occurrences of the taxon in the samples, and the abundance information there is. And the other thing that used to was already there since Kronos era is tables containing the age model. So the function that allows you to say that a sample from that depth from that site is that age, which is something that I'm going to go back later explaining. And then also we added a bunch of metadata, including like the source of the data set, because that's not something that was present before, and a massive stratigraphic layer, which I'm not going to explain here. I'm going to explain it later, because I think it's important and really unique to Neptune. So the content, by now there's almost 800,000 occurrences of microfossils, over 500 sites from the deep sea. You can see on the map, like all the red dots are the one we have microfossil occurrences recorded in Neptune. All the black dots are the one where we have already the metadata in, but not yet the microfossils. And you can see on that plot that shows the number of occurrences for each fossil group over the age. We have actually a very good Cenozoic record in particular. It's the Cretaceous is mostly carbonate microfossils, not so much siliceous microfossil, but we still have a lot of data. It covers almost 20,000 taxon species or genera. For 5 groups, actually, there's an extra group that I didn't mention because we just started entering it, which is dinoflagellate in purple. So the synonymy is all the data is entered with the original taxon as it was described in the original source, right? But we have a system to actually resolve the synonymy, which is based on a project called Taxonomical Namelist TNL, which was an effort from the International Ocean Drilling Program Paleontology Coordination Group, where they invited a lot of experts to actually give their opinion on which taxa were correct and whatnot. So yeah, this is what we're using now in the Neptune. What's really unique with Neptune that we have this system of, we don't just give an age like Miocene or Eocene or whatever, we actually give a numerical age, and it's based on the continuous age versus depth function for each section. It's called an age model. It looks like that. It's based on a lot of stratigraphic events, so that we now have in the database. So we have age model for like almost 500, 500 sites. And we estimate their quality qualitatively. By now, most of them are, let's say, good to excellent. And on the website, there's actually option to get rid of the poor age model if it's an issue for the analysis that you usually want to do. So this is a website actually. On the website, you can do searches, of course, for occurrences with a lot of options to filter the data. You can resolve the taxonomy, you can filter out site with poor age model, etc. I mean, like there's already a lot of options for quality control. You can explore just the taxonomy. You can just grab an age model that we made and see why we made it. Like we actually give at least some information on where it comes from. You can look for calibration of stratigraphic events or stratigraphic events that were observed in such and such sites, which is what we base the age model on. So you can grab basically everything that's in the database from the website. Yeah, I mentioned earlier, we have this really complex stratigraphic layer to the database because basically that's something that's really unique to Neptune as far as I know. So Neotoma is doing a lot in that domain as well, but it's that the age assigned to a sample is not a static piece of information, it's dynamic. We constantly update it based on available information. So we have a lot of metadata on the stratigraphy of each site, on calibration of stratigraphic events, on what's called GPTS here, the geomagnetic polarity timescale, which is the timescale on which all the calibration are calibrated. So why do we do that? Actually, I mean, I just wanted to explain the philosophy behind it. When you have an age for a sample, it's not data, right? It's interpretation. So it's based, in our case, it's a numerical age. So we base it on the age model, which is like this line of correlation that gives you age versus depth. This is not a data either. It's also interpreted. It's interpreted from stratigraphic data that are observed on the site. And those stratigraphic data, so they already come with some error margin, obviously, because we don't sample the site continuously. So there's already an error margin there. But it's also, there's also an error margin based on the fact that they're also calibrated. I mean, they're not, they don't carry the age with them. It's based on observation on other sites. So it's calibrated on the geomagnetic polarity timescale with geochronology, etc., which are things that are based on the standard or model that are occasionally updated. In fact, in the case of the GPTS, it's updated every 8 years. So it's quite a lot. Meaning that when you give an age to a sample, it comes with a lot of baggage expressed as a chain of metadata. And any link on that chain actually can change. And you want ideally that change to propagate to the end product, the sample, right? And if you don't actually store that chain of metadata, you literally cannot do that, which is why we went into this really complex structure. Okay, so as I implied in the name of this talk and what I said already about the history of Neptune, it's a legacy database, which means there's, there's a lot of things, unique issues with it. In particular, that issues that makes you spend, in the end, spend more time on quality control database than on actually inputting new data into it. And I think it's important and it needs to be, said. In particular, as I mentioned before, there was zero metadata at first because of limitations, and meaning that there's no, all the datasets that are in the database are not linked to the original publication. So we had to put that in, because if you don't put that in, for one thing, you cannot identify duplicates, which there have been some, because of course, the database, people have been entering data in the database since 35 years. They don't necessarily check it's difficult to check if the data is already in if you don't actually have the information about where the data come from naturally. Also, it was not possible to find mistakes in each of those data sets if you don't actually know where it come from. So it was really important to put that back in. And there was a lot of mistake because, of course, scanning technology and OCR technology was not, I mean, 10 years ago, it started becoming better, but before that, it was frankly not usable. And this is the kind of data people have been entering the database. I mean, it's this massive range chart with a lot of species, a lot of samples. It's very easy to skip a row, to misalign a cell, etc. It's yeah, but if you don't actually have know where the data come from, it's not possible to clean it. So which is what we had to do first, and then we spent months cleaning it. There's a lot of design choices that were made that of course are meaningless nowadays, but you know, they had to be made at the time. As I said, there was no metadata because no space, but also a lot of fields were restricted because of the standard at the time, but standards actually change in 30 years or so. In particular, and that's just an example from the top of my head, you saw in that chart before, there's actually a lot of those symbols that represent absence and not presence of data, which was a standard at the time. People used to do that. They were looking for biostratigraphic events. They didn't find it. They wanted to say that it was not there. And but 20 years later, nobody does that. So nobody understands that it's the case. So most users were using that as presence instead of absence. So it needs to be cleaned, right? So that's a lot of issues that you have to deal with. You have to update the taxonomy and stratigraphy, obviously. For the taxonomy, as I mentioned, we had the taxonomical name list. For stratigraphy, well, first you update the scale, but then you kind of have to redo everything because stratigraphy have evolved so much in 20 years that all these old age models are unusable, which is what we spent most of our time in the last 10 years doing, actually. First, we had to assess all those old age models to know what we are dealing with. Then we had to use statistical analysis to actually identify the main outliers, the main issue, the main issues in those age model or in specific age models, like in particular using this Pacman analysis. And then, so yeah, we had to do redo a lot of those edge models. We had to actually, we don't do them by hand, we use a software, and the software only exists because of Neptune. So it's only maintained or created by the people who maintain or create Neptune. So yeah, the first version was in BASIC, so it's for Macintosh 2, so it's unusable, obviously. The second version was in Java, which is widely outdated by now. And so I had to redo a software in Python to actually be able to do that workflow. And so eventually we were able to redo all the age model. Since 2014, we redid 350 of them, a bit more. And just in the last 3 years, Dave, since he's retired, basically just did 150 of them. So yeah, a lot of work there. Thankfully, now that we have the metadata, we can actually go a bit further in the quality check of the edge model. We can actually estimate quantitatively the quality. And so I'm very glad to see that if you actually filter out the poor and very poor edge model, you actually end up with samples which are dated with a standard error that's lower than 0.5 billion year, which I think is really good. Okay, we don't exist in a vacuum. We're actually linked to a lot of projects. I wanted to just highlight 2 of them. The first one is called Microtax. It's a series of online community catalog for microfossil taxonomy, created by Jeremy Young from the Natural History Museum in London. Originally, it was for nanofossils, so nanotax, and one for Planktonic Forum, and we've been helping him develop one for radiolarian since I and Dave are both radiolarian specialists. And so on that website, you can actually, For each species, you can actually see data from Neptune directly in the on the page, which gives you the, basically the occurrence through time of the taxa. And I really encourage you to go to the website. There's a bunch of other tools to explore microtax and Neptune combined. So it's really cool. Another project was Triton. So it's it's a bit the baby of Neptune. It's a database of just Cenozoic puncturing forum, and just for Cenozoic puncturing forums, they have 500,000 records. So it's 4 times a Neptune content of Cenozoic puncturing forum, because they added a lot of land section, which we cannot do because currently the database is really hard coded to get deep sea samples. A lot of surface element, etc. So they created a lot of new age model using machine learning. It's really cool. So if you want to access it, you can just go to the paper. It's actually in the supplementary material. Or you go to the website of Neptune, where you there's a dedicated page nowadays to actually download from Triton. Okay, I was asked to give some example of studies using Neptune. It's difficult to choose because there's at that point 152 publications. But here you can see 6 of the latest. That should give you an idea of the scope, actually. So it's mostly paleobiology, obviously. That's what why the database was created. But also a lot of theoretical biology, a lot of micropaleontology or stratigraphy case studies. Or more recently, a lot of paleoceanography, paleoclimatology, marine geology, where they're starting to do big data analysis, and they using Neptune age model capacities and stratigraphic metadata to actually do that. That's the case of the bottom 2 studies. Okay. Okay, the future of Neptune. So, well, yeah, it's not written in that list, but sorry. The current development team of Neptune, it's composed of 2 retired people and me, who's unemployed. So obviously the main task of the to-do list is to find a funding or a position or something to continue working on Neptune. That's right, but I also have some more concrete to do. In particular, currently I'm trying to create an API for the database because to facilitate actually other database remobilizing our information. We don't want the data or the metadata or all the edge model we made to be lost. So we want people to be using them. So we wanted to facilitate it. So currently it's just limited to edge models, but I'm working on an API for occurrences and events and etc. We want to add benthic microfossils because so far we've been focusing on planktic. But the deep sea drilling record is actually full of benthic organisms, particularly forams and ostracods. We just need experts for the taxonomy, obviously, because they were not part of the TNL project. We want to add land sections. So that will necessitate a new overhaul of the database, because as I said, it's really hard coded for deep sea drilling stuff. But for a lot of microfossils, at some point we are reaching a limit to what can be done with a deep sea fossil. In particular, diatoms, they have a very good shallow water record in the Paleocene and Earliocene that you can find in non-section, but in the deep sea, there's nothing basically. Okay, we need also a mirror site. That's very trivial, but currently the database is just on a single server in the museum here in Berlin. Every time there's a power outage, which is there have been a lot in the last year, the database is basically down for a couple of days. And at that point, there's several, sorry, excuse. At that point, there are several hundreds of users of the database. So it's really an issue. Okay. And the final item is something I discussed with Adam. It's a versioning of the database. I mean, it exists in 30 years. There's a lot of studies have been using it. At some point, we want to replicate the studies. It's not possible if you don't know what the database looked like at that time. So we are trying to actually, since I have daily backups since the last 10 years, basically, yeah, we're thinking of versioning the database. Okay. So before my voice completely gone, you can access database through the website, as I mentioned before. There's a R package you can use. And this software that I created to do age model, you can also find it on GitHub. And everything I said and everything I forgot, you can actually read it in that paper that we published in Paleontologica Electronica a couple of years ago. So thanks for listening. I hope I wasn't too long. Thank you.
Hi. Thank you. No, you were perfect.
Thank you.
I now invite anybody in the audience to please write your questions into the chat, and we'll go first with some of the ones that have come from other sources.
Yeah.
So I think one of the questions that we got were, what was the biggest hurdle in terms of the lifetime of the database? Is it more, and in terms of its development, is it funding or human resources, or a bit both?
Well, they're both linked right now because human resources is me and funding is none. So it's a bit of an issue. But no, overall, I think it's been funding, clearly. Human resource, actually, we've been very lucky. At least 6 or 7 years ago, we had a lot of volunteers who helped us. So it helped us a lot doing the data cleaning in particular. I mean, I'm really in debt to a lot of students who wanted to do something else than what they were doing. And so to help us for a while, it was really cool.
Yeah,
yeah.
It must take up a lot of your time too. I mean, I assume that this is really a considerable chunk of your overall working hours just to maintain the existing structures.
Yeah,
right?
Yeah, exactly. And yeah, to maintain the code as well. Yeah, it's
yes, it seems to me that it's almost impossible to do this just database development. You've done quite a lot of web design and software development and all these like additional things that were not supposed to, not supposed, they're sort of part of this job, but at the same time it's a considerable amount and it's completely hidden, right? So people will not be, they will not be exposed to how much how much resources are going into doing these.
Yeah, at least since 3 years, we have support from the institution. I mean, you know, they're actually maintaining the server itself and the software stack. But in the 10 years before that, it was not the case. So it was, it's, yeah, I mean, well, I learned how to do server management. It's nice. It's a useful skill.
And they don't even allow you to do that, right? It's
well,
it's something that they want to do. Yeah.
Well, yeah, it's a bit complicated. Yeah. But now it's yeah, it works better.
Yeah, and yeah, just out of like actually a personal curiosity, you mentioned this thing that age is always an interpretation when it comes to the samples. That means that there's quite a lot of computation happening, and you like shown more or less the chain of information or transfer functions that actually like lead to age results. How much code are we talking about? Can you quantify that in some ways to like just to give a hint about?
Well, I mean, just also just that software that I made to do actually do the age model based on the stratigraphic event. It's already something like 1,000 lines of code or something. I mean, of course, you know, a third of it is just a graphic design, as a user interface or whatever, but most of it is actually the computation. Yeah, and it's not even talking about what's before, which is not something that it's something that we take from the literature, like all the calibration and whatever. Like you know, with that we just took it from the literature and then we believe that you know what they are doing. But eventually we will maybe actually help with that step as well. But yeah, it's it's a lot actually.
Yeah, it's a lot, yes.
Yeah.
And it also makes you quite indispensable, right? I assume there is not a lot of people other than you who would understand that code at the moment, right? There would be if at least parts of the work was supposed to be done by somebody else, that would be in quite some time, the onboarding, right?
Yeah. No, definitely. I mean, that's actually why I wanted to focus talk on the legacy aspect, because something that's need to be thought of, because every single one of the database we're using right now, PBDB, whatever, they will become a legacy database at some point. I mean, at some point, there's going to be a team of people using it, taking care of it, that have no idea why the people before did the things the way they did, right? And so, yeah, you need to make sure that you're not losing knowledge, and even the smallest detail. I mean, why a specific column was coded the way it was and stuff like that. It's important to keep track of all that. Yeah. Particularly because, I mean, most people in our field are not paid to actually do that. So, so it's something I do on the side. So I don't necessarily have the time to document everything. And it's, yeah, that's, sorry.
Yeah, great, thanks.
You're welcome.
Okay, we have a question from the chat from Christina Sahakian, who says, first of all, thank you for the interesting speech. But the first question is, how deep was the deepest core within the sample and within the database, and where does it come from? And are you also working on pollen analyses? And what databases would you recommend or use?
Okay. Well, let's start with the second one because it's the easiest. Pollen analysis. We don't have pollen in Neptune. We start having dinoflagellates, which are usually collected by the same people on board the ship, at least. For pollen analysis, I would really advertise Neotoma. I think that's definitely the standard by now, at least for late Cenozoic, right? I don't think there's a Cretaceous pollen database as far as I know, but yeah. The deepest core. So the deepest core, I'm not entirely sure. I think it's like a kilometer and a half or something. I mean, the more you go deep, obviously, the less microfossils. I mean, a lot of microfossils start to be degraded, and because of the compaction, basically. That's as simple as that. But you have samples that are like, 800 or 900 meters below seafloor that are in Neptune. I think there's the mostly forams and stuff because they're bigger, they preserve better. Yeah.
Another question is, how many visitors does the database have, and how do you quantify that? Okay,
that's a hard one actually. So as I mentioned, since 3 years, so people from the museum actually are helping me with the server, which means that I don't have access to that information anymore. They do. Before that, basically we had something like 40 unique visitors a week. And we had, until last year, you had to register to look at the data. I had something like 150 to 200 registered users. By now, you don't need to register anymore. Plus, since years, you can per user data from microtext already without having to have so I would imagine it's 1.5 to 2 times that. So I think that's, yeah. But I mean, people are not using it every day, obviously. I mean, you would have to be a bit of an OCD going on, but it's usually just once, yeah.
So Mike Bidgood says that you might have mentioned it, and they may have missed it, but does the Neptune database have age limits? Like the histograms, do they correspond to the age ranges as quoted in Miratax, or are they separate and displayed alongside?
So the histogram that I show in the talk are mostly by category of age models, like very poor, etc. On microtext, the histograms are basically the number of sample of that age in which that species is present. So it's like a quantification of ubiquity, I guess. Yeah, because not all samples come with abundance data, so that was the best thing that Jeremy could think of. Yeah. So they're really two things really separate. Yeah.
I'm conscious of everybody's time, so we'll probably have maybe a couple of more questions before we wrap things up. But we have a question from Hirokina from Sri Lanka, but their tagline says Manavi. So I'm sorry if your name doesn't match up. And they say thank you for the interesting presentation. For paleontology students who don't have much expertise, how would they find the updated methodologies of sample preparation and counting and identification? Do you have any recommendations?
Okay. Yes, at least for the sample preparation and counting, I guess. Basically, that's one of the great things with the deep sea drilling program and I think the last one is International Ocean Discovery Program. Is that every single thing they published, data publication, everything is online for free. So you just go to the site of IODP, you look at publication, and for every single expedition, there's a chapter in the publication book. There's a chapter on the methodology, and for every single one, it's explained exactly how samples were prepared or samples were counted, etc. Yeah, for identification, it's a bit more difficult, but I would honestly, I would start with microtags by now. At least for the nanofossils and the planktonic forum, it's very complete. Radiolarian, we're just starting, but I mean, they're way more diverse as well, so it's gonna take years. But yeah, and the atoms, we don't have that resource yet, unfortunately. So yeah. Your best bet for diatom identification is to ask that diatomist that you know, I guess. Yeah, and yeah, so counting, yeah, as I said, you can find that in the IODP publication. Yeah, okay, I think I did that one.
A question from Diana Shoaib, who again, thanks you for the presentation, but how does the core database relate back to the physical location of the cores? Are you able to secondarily access them, or would you have to go through a host institution?
Sorry, can you repeat, actually? I didn't, that's something see it written, so yeah.
The structure of the database relates back to the physical core library.
Yeah.
I guess that's the brunt of the question. So
yeah.
So ground truth.
Okay. Yeah. So the samples, the way that that's why I meant by it's hard coded for deep sea drilling material. It's like the samples are really coded in terms of site, core, section, interval, which is the lingo from the deep sea drilling program, and what they do for in the core. Library, or how is it called, the repository. Yeah, so it's linked definitely.
Yeah, I think that's a really important point there, and something that Adam is very conscious of, which is always returning back to the evidence in your databases. Otherwise, it becomes too easy to get lost in interpretation as things change. So I think that we might want to start wrapping things up now. Adam, do you have any burning questions?
Just one more question, maybe, that Abel Ramirez asked. He says, many thanks for the presentation. And what considerations should be considered if the same taxa are reported in deep sea sediments and land sections? Could they be correlated?
Yeah. Of course. I mean, well, I mean, it's something to look at on a case-by-case basis, obviously. I mean, there's a lot of diachrony in, because of course a species, I mean, we're talking about microscopic organisms that don't live everywhere at the same time. They move, they migrate. I mean, they don't really migrate because it's a plankton, but the range actually contract and extend, etc. So it's a bit complicated, but yes, in theory, I mean, that's how biostratigraphy was founded, and that's basic idea. I mean, that yeah. at least regionally, if a species disappear at the same time, and you can use that for calibration. And, yeah.
Yeah, and actually it's sort of related to this, which is like mentioning of pollen and also land sections with Neotoma. Do you see a way how you can like share information at least, or has there been anything going on with the interaction between the two databases in some ways?
Yeah, something that we've been thinking for a while. It really just dropped down to the fact that I didn't have time to actually push into that direction. But yeah, I mean, what is called Neotoma has this thing with PBDB called the Earth-Life Consortium, right?
Yes.
It's a common API actually, and that's actually my main lead to for making an API for Neptune. It's to share it, with them, so that yeah, you can actually take data from 3 sources at the same time and not bother with going separate database. Yeah, I think it's really yeah, the key.
Yes. So you will develop this REST API on your own?
Well, currently, yes, but I mean, because I coded the website in Django, actually, it's fairly easy to do a very basic API, at least that's usable using Django. But there's difference between doing a basic API and doing an actual proper API with a proper ontology that actually can be shared between different domains, etc. So that I won't be able to do it myself. Obviously, I will have to
Yeah, very impressive.
to work with them. Yeah.
Yeah, that will be really, really useful.
Yeah.
Awesome.
Well, that was all fantastic. I think just before we close out the meeting, I would just like to remind everyone that next week's talk will be by Dr. Shannon Peters on the paleobiology database and MacroStrat. So we look forward to seeing you there.
Yes.
And I guess we can stop recording now.
Yeah.